Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at LearnoHub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 3 Laws of Motion. In the previous class, we have discussed Newton's second law of motion. A small portion is remaining which we will be discussing today, and Newton's third law of motion will also be discussed. Also, we will be solving some problems from exercise 3D. Are you ready for the session? Let's begin. Newton's second law of motion in terms of rate of change of momentum. Here you can see a boy is pushing a car, which means he is applying a force. When he applies a force, so what happens? The car starts accelerating. That is, the velocity is changing. Hence, momentum is changing. With respect to time, what is happening? In a given time interval, there is a change in momentum. How do we represent change in momentum? Delta P is the change in momentum. Delta is used to represent a small change in time delta T. Change in time. You know, time is always changing. Time cannot be a constant. So, with this change in time, what is happening? The momentum is changing. And we have studied that the rate of change of momentum with respect to time is equal to the product of mass and acceleration is equal to mass into acceleration, or delta P by delta T is equal to ma. Let us take this as equation 1. We have studied this equation. The rate of change of momentum is equal to the product of mass and acceleration. One more equation we have studied. What is force? Force is the product of mass and acceleration. Yes, F is equal to mass into acceleration. So, this is the second equation. Comparing these two equations, we understand right hand side we have mass into acceleration, here also mass into acceleration, which means if right hand sides are equal, left hand side should also be equal. We already have delta P by delta T. What is delta P by delta T? Will be equal to delta, momentum is mass into velocity, delta mv divided by delta T. Now, let us take mass as a constant. In cases where mass is a constant, we can take mass outside, then delta V by delta T. Okay, m delta V by delta T. Or this is equal to m into A. Delta V by delta T is mass into acceleration. Just by comparing, you will be getting delta P by delta T is force. Okay, ma is force. Therefore, we can say force is equal to rate of change of momentum. Clear? Force is the rate of change of momentum. We know force is mass into acceleration, which is a mathematical expression for Newton's second law of motion. We have studied in the previous class. Okay. So, according to Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the force applied on it, and the change in momentum takes place in the direction in which the force is applied. So, here this conclusion can be made, that is F is equal to delta P by delta T, or F directly proportional to delta P by delta T. When change in momentum increases with time, force also increases. When force increases, the change in momentum increases. How does force increase? Here, if the boy is pushing the car with a great force, what happens? The change in velocity will increase, acceleration will increase, hence momentum will also increase. Okay, then delta P will increase, right? So, they are directly proportional. Okay, also you can see there is no negative sign here, which means the direction will be the same. In which direction force is applied, momentum change will also be in the same direction. Clear? Now, we have said that force is equal to change in momentum by change in time, that is equal to change in mass into velocity by change in time is equal to mass delta V by delta T equal to mass into acceleration. Now, here you can see that mass is taken as a constant. In most cases, there are increase in mass with increase in velocity. Okay, when velocity increases, mass also increases. These are cases where the velocity of the body is comparable to the velocity of light. Okay, speed of light. What is speed of light? Speed of light is represented by c, and that is equal to 3 into 10 raised to 8 meter per second. If the speed of a body is the velocity of a body which we have taken is greater than or somewhat equal to, approximately equal to 3 into 10 raised to 8 meter per second, in that cases, with increase in velocity, what happens? The mass also increases. But normally we can say that normally the bodies does not move with the speed 3 into 10 raised to 8 meter per second. Yes, in that cases, that is velocity less than the speed of light. In that cases, we can take mass as a constant. Okay, mass will be a constant. So we know that the change in momentum happens. One thing is by change in mass. Okay, velocity is a constant, like P is equal to V delta M by delta T. Okay, change in mass. In that case, velocity is a constant. Or second, change in velocity. P is equal to M delta V by delta T. Or change in both M and V. That is delta P is equal to delta MV by delta T. Now these two cases are possible, that is P is equal to V delta M by delta T or delta P is equal to delta MV by delta T. These are possible only when the speed of the body is comparable to the speed of light. If the speed of the body is very less than the speed of light, only this case is possible, that is change in velocity. Okay, mass will remain a constant, M constant. Okay, so what are the conditions? When velocities are much smaller than the velocity of light, and second, when mass remains a constant. Clear? Newton's first law of motion from Newton's second law of motion. Second law of motion, we have studied the mathematical expression F is equal to M into A. Here mass is a constant. If F is equal to 0, that is no force is applied. In that case, mass cannot be 0 because mass is a constant value. Acceleration should be 0. Yes, if the boy is not applying a force, what does it mean? The car has a mass, but the acceleration will be 0. The body is not moving, it has no velocity, it has no momentum, no acceleration. Okay, acceleration will be 0. If acceleration is 0, we can say that the body is at rest. Okay, so a body at rest remains at rest when no force is applied, when force is equal to 0. Okay, also if a body is moving with some velocity, no force is applied. If no external force is applied, the body will continue to move with the same speed in the same direction. Okay, so what is the statement of Newton's first law of motion? A body remains in a state of rest or uniform motion along a straight line unless an external unbalanced force acts in the direction of force. So here, if no force is applied, the body will remain at rest or the body in motion will continue to be in motion with the same velocity. Clear? Okay, so a body not acted upon by any external force does not change its state of rest or of motion. So this is the statement of Newton's first law of motion. We have obtained Newton's first law of motion from Newton's second law of motion, F is equal to ma. Examples of second law of motion in daily life. Okay, so we have force is directly proportional to the rate of change of momentum. F directly proportional to delta P by delta T or F is equal to delta P divided by delta T. Okay, from this we can write delta P will be equal to F delta T. Okay, so when does a change in momentum happen? Okay, either it can be when a large force is applied for a small interval of time or a small force is applied for a large interval of time. Okay, now take these cases. Here what is happening? You can see a nail and a hammer. Okay, so he is hitting the nail with a hammer. So what is happening here? A large force is applied, okay, for a small interval of time. If we are applying a small force for a large interval of time, will the nail go inside? No, right? So in this case, F should be high, delta T should be small. If the time interval increases, what happens? It is difficult for the nail to go inside. So large force should be there for a small interval of time. So just imagine if your friend is beating you, okay, is hitting you, he will be applying a large force for a small interval of time. Then the impact is higher, right? If the same person is hitting you for a large interval of time with a small force, you won't have that much of impact and you won't get hurt much. Okay, this is the same case. Now here you can see the batsman is hitting the cricket ball. Okay, while hitting, depending on the force, the change in momentum will also be higher or lower. Okay, we know in this case F should be high. Higher force if he is applying for a small interval of time, the ball will move more. Okay, ball will move more means the change in momentum is higher. Okay, if the same person, the cricketer, what he does is he is applying a small force. Okay, if he is applying a small force for a large time interval, what happens? It will not be, he won't be able to move the ball for a longer distance. That is, the ball cannot gain greater velocity, which means the momentum change will be small. Okay, so change in momentum of a body can be brought about either by applying a large force for a small duration or by applying a small force for a long duration. Clear? Athletes often land on sand or foam after taking a high jump. So after a high jump, you have seen that there will be sand. Okay, for example, if you take high jump, what happens? You will be landing on a sand. So what is the reason for this? This is because when you land on a hard floor, what happens? There we have delta P is equal to F delta T. Okay, when you are landing on a hard floor, what happens? The time interval decreases. Okay, for your body to come to rest, the time interval decreases, which means the force will increase. When force will increase, the impact will increase and the chances of injury will increase. Okay, and you will get hurt more. But when you are landing on a sand, okay, what happens? The time interval will increase. Okay, larger change in time, which means the force will decrease and the impact will decrease, injury will decrease. Okay, the change in momentum will be the same in both the cases, but by landing on a sand, what happens? The time change will increase. Okay, time interval increase, therefore the force will decrease. Okay, and the impact will decrease. Clear? So, in order to avoid the injury, this is done. Now, take this example. When glass vessel falls on a hard floor, they break, but they do not break when they fall on a carpet or sand. So, you have experienced this. When you take a glass vessel, a glass, and drop it on a hard floor, what happens? It breaks suddenly. It gets broken suddenly. But if you are taking a glass and dropping it on a carpet, what happens? It doesn't break. There are very few chances of it getting break. So, what is the reason here? Again, the same thing, force is directly proportional to rate of change of momentum, and rate of change of momentum is equal to force into delta T. Okay, so here you can see when time interval decreases, force increases. Okay, here when the glass is dropped from a height on a hard floor, what happens? It falls and breaks suddenly. So, the reason is time interval is very small. Okay, as soon as it falls on the floor, it gets broken. That is, time interval is small and hence the force will be higher. Okay, the floor will be applying a greater force on the glass and it will get break. Okay, now this case, here you can see when it is dropped on a carpet, so it will take time to reach. Okay, in that case, what is happening? Time is increasing and hence the force applied by the carpet on the glass will be less. With less force, the chances of it getting broken will be less. Let us take an example. A cricket ball of mass 100 gram moving with a speed of 30 meter per second is brought to rest by a player in 0.03 seconds. Find the change in momentum of ball, the average force applied by the player. Here what are the given quantities? We are given mass M is equal to 100 gram. We have to convert it into kilogram. What is 100 grams in kilogram? 0.1 kilogram. Okay. With the speed of 30 meter per second. Initial velocity. Initial velocity U is equal to 30 meter per second. Is brought to rest by a player in 0.03 seconds. Final velocity V is equal to, it is brought to rest, which means final velocity is 0. Okay. Time is given, change in time, delta t is equal to 0.03 seconds. So, the first part of the question, we have to find the change in momentum of ball. Change in momentum. Delta p is equal to, what is change in momentum? Here, we have initial velocity, final velocity and mass. Change in momentum will be mass as a constant, delta V. That is mv minus u, which is equal to 0.1 into V0 and U30. Okay. So, 0.1 into minus 30, which is equal to minus 3 kilogram meter per second. Okay, minus 3 kilogram meter per second. Next, the average force applied by player. How to find the average force? So, today we have got a relation. Initially, we had delta P by delta T is equal to mass into acceleration. Force is equal to mass into acceleration, from which force is equal to delta P by delta T. Force, average force will be equal to delta P is minus 3, delta T is 0.03 seconds. Okay. So, how much do we get? This becomes minus 300 divided by 3, which is equal to minus 100 Newton. Okay. So, the force, average force is minus 100 Newton. Clear? Now, we will move on to Newton's third law of motion. Newton's first law of motion, a body remains in a state of rest or uniform motion unless an external force acts on it. From Newton's second law of motion, it gives the magnitude of acceleration depending on the force. F is equal to ma, mass is a constant and the acceleration change happens depending on the force. Greater force, greater acceleration. Smaller force, smaller acceleration. Now, both these does not define how force acts on the different bodies. Okay. So, Newton's third law of motion defines how the force acts on the bodies. Now, let us take an example. Here you can see a book is lying on a table. Okay, we know gravity is acting downwards. Does the book fall down? No, right? So, what is the reason? So, here in this case, the book is applying a force, that is the weight of the book in the downward direction. Some other force is balancing it. Okay, otherwise it should fall down. So, which is this force? Here you can see the table. Okay, now this table will be applying an equal and opposite force. So, the book is applying a force on the table in the downward direction. An equal and opposite force is applied by the table on the book in the upward direction. Okay, this should be equal. If the book is applying a greater force, then the book should fall down. Okay, but here they are balanced and hence it helps the book to stay on the table because the table is applying a force which is equal and opposite to the weight of the book. Okay, now take the second example. Here you can see a boy and the dog is moving forward. How they are moving forward? They are applying a force on the ground. Okay, so they are applying a force on the ground to push the ground backward. Okay, so they are pushing the ground backward. They should move forward. For that, the ground is applying an equal and opposite force on his foot to move him forward. Okay, so equal and opposite forces there. One is in the backward direction the boy is applying force on the ground. And in the forward direction, the ground is applying a force on the boy's feet. Got it? So, we'll state Newton's third law of motion. To every action, there is an equal and opposite reaction. In the first case, the action forces the force applied by the book on the table, that is the weight of the book. And the reaction forces the force that is acting in the opposite direction, that is the force applied by the table on the book. In this case, the boy is applying force on the ground, this is the action force, and the force applied by the ground on the boy is the opposite force, that is the reaction force. Okay, got it? Now consider these two cases. So what is the statement? To every action there is an equal and opposite reaction. Okay, here let us say the book, we can represent the object as A and the table as B. Force is applied on B by A, which we can represent as FBA. Okay, so FBA is the weight of the book or the force applied by the book on the table. Okay, now this is acting in the downward direction. Okay, next we have FAB, that is the force that is applied by the table on the book, which is in the opposite direction. So this FBA and FAB will be equal in magnitude. Okay, if the value of FBA is 10 Newton, FAB will also be 10 Newton. So the difference is they are in opposite direction. One is in the downward direction, the other is in the upward direction. Okay, now again in this example, the force that is applied by the boy on the ground, that we will be taking as FBA. Okay, FBA will be in the backward direction. Okay, and FAB will be in the forward direction. Okay, that helps him to move. This FBA and FAB will be having the same magnitude. Okay, they are having the same magnitude. The direction is different. So, difference in direction we can represent by negative sign. Okay, represent by negative sign. If F1 is the first force and F2 is the second force. F1 is action force and F2 is reaction force. Okay, then F1 will be equal to minus F2. Negative sign represents the change in direction, opposite direction. Okay, so here you can see there are two forces and these two forces are acting on two different bodies. Okay, in an interaction of two bodies A and B, here book and table, the magnitude of reaction, the force FAB applied by the body B on the body A is equal in magnitude to the action, the force FBA applied by the body A on the body B, but they are in directions opposite to each other. Understood? So, there is interaction between the forces on the two bodies and two bodies are present in this case. Okay, there are two bodies and two forces. Remember these things. Okay, action and reaction are two forces and they are acting on two different bodies. Now, my question is, do action and reaction force cancel? We have said that action force and reaction force are equal in magnitude. Let's say action force is F1 and reaction force is F2. Action force and reaction force is F2. Okay, we have said they are equal in magnitude. F1 is equal to F2. The magnitudes are equal. What else we have said? They are in opposite direction. One is in this direction, the other is in this direction. Okay, if one is in the upward direction, the other one will be in the downward direction. They are in opposite direction. Because of this, we have a negative sign. F1 is equal to minus F2. Okay, if F1 is equal to minus F2, in that case, they are having equal magnitude, they are in opposite direction, one is positive and the other is negative. When you take the net outcome or the net force will be 0. Why? Because they are equal in magnitude and opposite in direction. So, why do we? The question is, do these forces cancel out each other? Do you know the answer? So, here you can see the boy is moving out of this. Okay, so here he is applying a force, that is action force, in this direction, and the boat will be moving in the opposite direction. Why? Because of this action force, there is a reaction force. So you can see that there are two bodies involved. One force is applied by the boy on the boat. Okay, one force is acting on the boat. Let's say F1 is acting on the boat and F2 is acting on the boy. Okay, so here there are two forces, but they are acting on two different bodies, and due to this reason, they do not cancel out each other. If both of these forces were acting on the same body, then they are in equal magnitude and in opposite direction, it gets cancelled out each other. But here you can see that action and reaction force being equal, but they are acting on two different bodies, and due to this reason, they do not cancel out each other. Okay. So action and reaction never act on the same body, but they always act simultaneously on two different bodies. That is, the forces of interactions are always in pair. Okay, action and reaction is a pair of forces. Now we'll discuss some examples of action and reaction forces. A book on a table. Here we have already discussed this. We'll just say, so here we have the book. So book is the first object A and table is the second object B. FAB is the action. FBA is the action force, the force that is acting on the object B, that is applied by A, and FAB is the reaction force. Okay, so here action force is the weight of the body and reaction force is a normal reaction force. Normal reaction force is in the upward direction and action force is in the downward direction. They are in opposite direction. Okay, there are two bodies. Here we have a pair of forces, action and reaction forces. So due to this reason, what happens? The book is balanced. Okay, the force that is acting on the book is balanced and the book does not fall to the ground. It does not move. Second example, pushing a wall. Just try to push a wall. What happens? When you push a wall, you are applying a force on the wall. Okay, in the forward direction. So we'll be taking A as your palm and the wall as B. So FBA, the force applied by A on B. Okay, FBA is in this direction. Okay, towards the east direction, there is FBA. Now, this boy will be able to experience an opposite force. Okay, if he's just moving, the wall should have moved forward. But here the wall is not moving, which means the wall is applying a force in the opposite direction. So this force that the wall applies on the opposite direction is FAB, the force applied by object B or object A, okay, which is in the opposite direction. Okay, so here this boy will be feeling a force. Okay, this force is the reaction force that the wall is applying on his palm. Okay, so FBA and FAB will be of equal magnitude but in opposite direction. Okay, understood? Motion of a boat moving away from the shore. Okay, here the shore will be there. Okay, so using a bamboo, she will be able to row the boat. Okay, initially when he is getting into water with the boat. Okay, with the bamboo, she will be applying a force on the shore in the backward direction. Okay, this force is FBA. Shore is B and the bamboo used is A. Okay, so A is applying a force on B, which is FBA. Okay, so when the shore is pushed backward, what happens? The shore will apply a force on the bamboo. Okay, that is on the boat, and the boat will be able to move forward. Okay, this force will be acting in this direction, which is the force applied by B on A. Okay, then FBA, which is the action force, and FAB, which is the reaction force, will be in equal magnitude but in opposite direction. One in this direction, the other in this direction. Okay, and due to this, the boat will be able to move forward. Okay, rowing it backward, the boat will move forward. Now here, motion of a boat in water. Previous was to move the boat from the shore to the water. Okay, so here using the bamboo, what is happening? With the bamboo, a force is applied on the water. Okay, in the backward direction. This force is FBA. So here bamboo is the object A and water is the object B. Okay. So with the bamboo on the water, force is applied in the backward direction. So that is FBA. So water will be applying a force on the bamboo and hence a boat in the opposite direction, which helps the boat to move forward. Yes, this is the force applied by object B on object A. So here again, the force applied by object A on object B will be equal and opposite to the force applied by object B on object A. Okay, here bamboo and water are the object and this is how the boat will be moving forward. Okay, so if somebody asks you what is the reason for a boat moving in water, what is the reason? So this is what is happening and it is an application of Newton's third law of motion. Okay, due to action and reaction forces, the boat is moving forward. Firing a bullet from a gun. Okay, this is a very important example. So firing a bullet, when a man fires a bullet, the gun is applying a force on the bullet. In which direction does the bullet move? Bullet is moving in this direction. Okay, here gun we will be taking as object A and bullet as object B. Okay, so FBA is the action force. That is the force which is applied by gun on the bullet and the bullet is moving forward. Okay, when the bullet is moving forward, you will experience that the gun will be moving backward. Okay, there will be a sudden jerk and the gun will move backward. So what is the reason for gun moving backward? This is an action force. There will be a force that is applied by the bullet on the gun, which is FAB. Okay, this is the reaction force. That is bullet applying the force on gun. Okay, one is in this direction, action is in this direction and reaction is in the opposite direction. Action force FBA, reaction force FAB, they are in opposite direction. They are in equal magnitude but in opposite direction and they are acting on two different bodies. The bodies will be moving in two opposite directions. So you can see rocket propulsion. Here what is happening? Rocket is moving in the upward direction and you can see the fuels, the gases are moving in the opposite direction. Okay, due to high pressure and high temperature inside a rocket, what is happening? Forces are applied on the gases. Forces are applied on the gases in the downward direction. Okay, so this is the action force. Action force. Rockets is applying force on gas. Okay, so here rocket is A and gas is B. Okay, so FBA. Okay, now due to this action force, there is a reaction force in the opposite direction. That is the gases, the force on gases. Gases will be applying a force on the rocket in the opposite direction, that is upward direction, and the rocket will be able to move in the upward direction. Okay, this is the force the gases apply on rocket, which can be represented as FAB. FBA and FAB are in equal magnitude and opposite direction. One is in the downward direction and the other is in the upward direction. So you can see, okay. So if somebody asks you how a rocket is moving, so this is the reason. Yes, clear? Motion of a man on ground, this also we have discussed before. A is the man and B is the ground. Okay, B is the ground. Here a man applies force in the backward direction. His foot is applying force in the backward direction, which is FBA. Okay, in the backward direction. Now the ground will apply a force FAB in the opposite direction, that is forward direction, which helps him to, his foot will move forward and he will be carried forward. Okay, so this is what happening here. FBA and FAB are equal forces, they are in opposite direction. Okay, this helps the man to move forward. Now motion of a boat away from the shore while stepping down from it. So while stepping down here, what happens is, to step down, the person will be applying a force on the board of the boat. Okay, so that force will be in this direction. Okay, he should move in the forward direction to come out of the boat. Yes, so the boat will be applying a force on his foot in the forward direction and helps the person to come out of the boat. Okay, so normally the boatsman, what he does is he will be boarding the boat at the shore. Okay, boarding at the shore, it won't move further backward. Okay, and he can easily come out of the boat. Clear? Ninth example of action and reaction forces. Catching a ball. While catching a ball, what is happening? A ball is applying a force on the cricketer's hand. Okay, so ball is applying a force on hand. This force is FBA. Okay, ball applying the force on his hand. Okay, FBA is the force. Now, when the ball applies a force on his hand will be applying a force on the ball. So, ball should be brought to rest. To bring the ball to rest, FAB force is applied. So, FBA is in this direction and FAB is in the opposite direction, which helps the ball to come to rest. Okay, FAB is his hands is applying a force on the ball. Okay, hence ball comes to rest because they are equal forces and in opposite direction. Clear? Let us take a question from exercise 3D. Question 1. This is a multiple choice questions. Newton's third law of motion. First, the options are defines a force qualitatively. Second option, defines a force quantitatively. C, explains the way a force acts on a body, gives the direction of force. So, what is Newton's first law of motion? A body remains in a state of rest or uniform motion unless external force acts on it. Then Newton's second law of motion, F is equal to m. Rate of change of momentum is directly proportional to force. So, defines the force quantitatively. Newton's second law of motion is defining the force quantitatively. What about Newton's third law of motion? For every action, there is an equal and opposite reaction which acts on two different bodies. Okay, explains the way a force acts on a body. Okay, so this is the option for Newton's third law of motion. Clear? So, gives the direction of force. Direction of force is also given by Newton's second law of motion. Second question of exercise 3D, action and reaction act on the same body in opposite direction, different bodies in opposite direction, different bodies but in same direction, same body in same direction. What is the statement for Newton's third law of motion? Action and reaction are equal and opposite forces that act on two different bodies. Okay, they are in opposite direction. Yes, we have F1. If F1 is the action force and F2 is the reaction force, F1 is equal to minus F2. They are acting on two different bodies. We have seen many examples. They are acting on two different bodies and they are in different directions. Okay, so different bodies in opposite direction is the right answer. Clear? Question number 3 of exercise 3D. A boy pushes a wall with a force of 10 Newton towards east. So here, east, west, north, south. Okay, the boy is applying a force on a wall which is of 10 Newton towards east. This is east. What force is exerted by the wall on the boy? Now, let us take this as FBA. B is the second object, that is wall, and his hands we are taking as the first object, A. So, FBA is the force applied on wall by the boy with his hands, which is 10 Newton east. Okay. Now, we are having FBA is equal to minus FAB. FAB will be the force applied by the wall on the boy. Okay. So, what will be the magnitude? You can say that FAB will be equal to minus FBA. Okay. If it is minus FBA, FBA's value we know, which is 10 Newton. Okay. Minus 10 Newton. FAB will be equal to minus 10 Newton. So, the magnitude will be 10 Newton itself because they are equal. Newton's third law. The forces will be equal but in opposite direction. If the force FBA is towards east, here you can see a negative sign, FAB will be towards west. Okay, towards west. Understood? So 10 Newton towards west is the force applied by the wall on the boy. That's all for today. In today's class, we have discussed Newton's second law of motion in terms of rate of change of momentum and Newton's third law of motion. We have also discussed many examples for Newton's second law of motion and Newton's third law of motion. Also, we have solved questions from exercise 3D. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.